Welcome back. So we learned so far that law of conservation of mass says that during a chemical reaction, the atoms are not destroyed and new atoms aren't being made. So this kind of makes sense. When you burn, like we use the example, when you burn a log, okay, the fire is not actually destroying atoms. Okay, so like mass is not going down. It's changing from being wood into ashes and smoke, and some of the water is evaporating, going up the chimney, but atoms aren't actually being destroyed. So when we have these chemical equations, we need to check for balance. This is one of the things that's in the 8th grade curriculum this year. So we have to make sure that the law of conservation of mass is met. So balancing a chemical equation, both sides of the equation have to have the same number of atoms of each element. So we're going to have to count them. And we can change it by placing new coefficients in front of the formulas or the symbols. Now, we can't change the subscripts. When we change the subscripts, we would be changing like the ingredients in the reaction. Okay? The coefficient changes the number of atoms and units of a compound that are in the equation. So making a balanced chemical equation. First thing we need to do is we check for balance. We count the number of atoms of each element on both sides of the arrow. Then we place new coefficients where needed. We have to recheck for balance until we're finished. Okay. I put in here, this is going to take some practice. It will get easier, I promise. Okay, so I mean, at first this seems really hard for kids, and then they catch on. So I know that if you do a little practice, you're going to be able to get this. If you don't do any practice, it's just going to stay hard. Okay, so we're going to look at this the way this is written. It says we have H2, which is diatomic hydrogen, plus this O2 is going to yield or produce a water molecule. And each water molecule is 2 hydrogens and 1 oxygen. Okay, so we're going to count at the beginning. In the H2, there's 2 hydrogens. In the O2, there's 2 oxygens. Each water molecule, there's 2 hydrogens and 1 oxygen. That's its formula, H2O. This is not balanced. The oxygens are out of balance. There's more on the reactant side than there are on the product side. So we're going to start right here. This is what's wrong. The only way we can have more oxygen over here on the product side is by putting the 2 coefficient in front of the water molecule. Now remember, this 2 coefficient applies to the whole formula. It's literally saying now we're making 2 water molecules. When we do that, there's going to be 4 hydrogens and 2 oxygen, because each water molecule has 2 hydrogens and 1 oxygen. The other way we can do this is we can multiply. 2 times 2 is 4, and then remember there's no subscript here, it's a 1, so 2 times 1 is 2. Okay, so we fix the oxygen. The oxygen is balanced. We have 2 on the reactant side and 2 on the product side, but when we fix the oxygen, we broke the hydrogen. And now we have 2 hydrogens on the reactant side and 4 on the product side. So we're going to put a 2 coefficient here, and when we do that, we're going to make 2 H2s. So 2 times 2 is 4 hydrogens. Now if we check, we have 4 hydrogens on the reactant side, 4 hydrogens on the product side, 2 oxygens on the reactant side, 2 oxygens on the product side, so this is balanced. And remember, there's an understood one here. If you're doing these things online and submitting them electronically, you need to put in the 1, because a computer doesn't really take an empty space. Let's take a look at how we would do this one. Okay, so it says Na, which is this sodium, and this is elemental sodium, plus this Cl2, which is diatomic chlorine. And remember, that's the way we find most of the nonmetals, is these covalently bonded compounds. And then it says it's going to make an NaCl. And that's the way salt is. There's one sodium and one chlorine. So we're going to count the number of sodiums. There's one. And in Cl2, there's 2 chlorines. And then in each compound, each unit of the compound of salt, there's 1 sodium and 1 chlorine. So what's the problem? The problem is the chlorines are not in balance. There's more here on the reactant side than there are here on the product side. The only way we can have more on the product side is by changing the coefficient in front of the salt. Okay? We're going to make 2 units of the salt compound. When we do that, we make 2 of this whole thing. So we're going to have 2 NAs and 2 CLs, okay, because we're making 2 salts. And each salt has 1 NA and 1 CL. So another way, there's a 1 here and a 1 here. Remember, there's an understood subscript, so 2 times 1 is 2 sodiums, 2 times 1 is 2 chlorines. Now the chlorine is balanced. We have 2 on the reactant side and 2 on the product side, but we have more sodium on this side than we do this side. So we're going to put a 2 here in front of the sodium and say we use 2 of this elemental sodiums. And that means there's going to be 2 of them going in, and that is now equal to what's coming out. 2 sodiums in, 2 sodiums out. 2 chlorines in, 2 chlorines out. And remember, there's a 1, an understood 1 here in front of the Cl2. So this is kind of a process of trial and error. You got to go back and forth. You got to count the atoms on this side, the atoms on that side. Start with the one that is the problem. It's the worst one out of balance. Adjust the coefficient, recount, and readjust the coefficients until you get them in balance. Okay? I promise it's going to take some practice, but it will get easier. Okay, I want you guys to answer these questions independently, and then we'll pick up here next time when we come back. Hope you guys are having a great day, and we'll see you soon.